With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a sphere start rolling down an inclined plane of inclination theta. Find the speed of its center when it has covered a distance L. So if you see, let's suppose this is the inclined plane and inclination of this inclined plane is given here is theta. So a sphere is started from some height and it traveled L distance along the incline, right? So yeah, this angle is given here theta. So when it will cover L distance along the incline, then you can calculate this height through which it came down. That will be L sine theta. So when the sphere came L sine theta downward, then you have to find out the speed of its center. And it is also said that it is rolling down, right? So since the sphere is rolling down, right, then the point of contact will have the same velocity as that of this point on incline, right? So if I say this point is A and this point is B, then the 2 points will have the same velocity and acceleration, right? So let's suppose this is the sphere and the sphere is having at any instant v velocity down the plane, and because of the rotation it have omega angular velocity in this direction, and this point of contact A have the same velocity as that of any point on inclined plane B, right? So I will write here v minus omega r is equals to velocity of point A, it should be velocity of point B, equals to velocity of point B. So I will write VA minus omega R is equals to 0. From here you will get V equals to omega R. Very simple. Now when it will came down by L sine theta, right, we can apply the work energy theorem, and only force which will do work here is gravitation force. Since friction force, if you see, this point of contact is at rest, right, it don't have any velocity, it is performing pure rolling, so the point of contact don't have any velocity, right? So I will write work done by gravity is equals to change in kinetic energy, right? That is translational plus rotational kinetic energy minus initially it is started from rest, so initially it was 0. So work done by gravity will be minus mg h, and change in kinetic energy half mv square plus half I omega square. And since this is a sphere, so I will be equals to 2 by 5 mr square, right? So it is also given that v equals to omega r and omega equals to v by r, right? So here the plus sign will come since it came downward, right? So I will write mgh is equals to mv square by 2 plus half 2 by 5 m r square. Omega square is v square by r square. So this will get cancelled out, right? Okay. So this m will also get cancelled out. So you will get gh is equals to v square by 2 plus 2 by 10 v square, that is 7 by 10 v square. Now the h is equal to L sine theta, right? So I will write 10 by 7 g h is L sine theta is equals to v square. So finally you will get the v, that is the velocity of the center of mass, is equals to under root of sine theta. Very simple, and this will be the answer. Simple. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.